Hello, and welcome to another episode of Maths in an Empty Classroom with me, Mr. Sutton. This is part one of the lesson on resolving forces, and in this video I'm just going to be annotating a diagram to show how we resolve forces that are acting at an angle. So here we are, we have a situation where we have a single particle here, a box, and it's being acted on by a single force here, which is at an angle to the horizontal. So I'll just draw that in a bit darker. This force here we've labelled T, which would generally stand for tension, and it's acting at an angle theta here to the horizontal. Now we just need to think about the forces that are going to be acting on this particle, and one of the forces that's going to be acting on it is its weight, which is going to be mass multiplied by gravity. That's if we say that the particle has a mass of m kilograms, where m is a value that we would either know or could work out. So this force we're going to have down here is its weight. We're going to have a normal reaction force, which is exerted from the surface that the box is on up on the box. Now, without this force here, this reaction force and this weight would be equal to each other. But the fact that we've also got this additional tension force means we've got something else to consider here. And this is what we talk about resolving forces. Now, when the particle is on a horizontal surface like this, we tend to resolve horizontally and vertically. So what I'm just going to do is draw in component arrows, which are the horizontal and vertical components of this force. So there's the horizontal one, and in there goes the vertical one. And I draw these with dashed lines, and I do that to show that they are different to the force itself. They are the components of it, horizontally and vertically. Now, the vertical component of this force is opposite to the angle, so this is going to be T sine theta, where T is the magnitude, the value of the force. And this one, going along here, because this is adjacent to the angle, this is going to be T cos theta, again where T is the force and theta is the angle. Now, we would be resolving horizontally to find the acceleration of the particle. It might well be that there were some resistive forces going on here, perhaps friction, but we're not going to look at that in this one. But if we were to resolve horizontally, vertically I should say, what we need to realise is that the total forces up are going to equal the total forces down, because vertically this particle is in equilibrium. So if I was using that to find the value of r in this case, I would be saying that r plus t sine theta, so that's the two vertical forces going up, must be equal to the one vertical force going down, which is mg. And if I knew those values, I could use that to find forces and active forces. Right, join me in the next video where I'll go through a specific example of that. See you then.